The belt is similar to long plank is what? The belt. So let me call this a belt. The belt is moving with a velocity v naught. Block, yeah, v naught, I'll write it. Velocity of the belt, let me write vb. Now, so this is rough. The belt is moving, let's not bother. It is moved with a constant velocity. I will place a block of mass m. I'm going to place on a belt at point P1. Then at t equals 0, at t equal to 0, at t equals 0, a block mass m is placed on belt at point P. Okay, got this. At t equals 0, a block of mass m is placed on belt at point P. So he's asking now, find the time at which block comes to rest with respect to belt. So I'll just place it, means I'll drop it on the belt. What is the state of belt? Belt is moving. So what conditions will arise here? It's a long belt. Now, after some time, what you see, the belt will be at some other position and the block has landed here. So the same diagram, I'll continue. So this is the and the block is placed here at point P1. Now look at that one. In what action the friction should act here? Velocity of the block with respect to belt you calculate. Or velocity of this, like a particle or anything. Velocity of the block with respect to belt. So can we, with that, shall I say the friction will act on the, I'll move a little bit down. Okay, now let's come to the thing now. How the things should act here now. So velocity of the block with respect to platform. I think I'll call belt or platform. I'll use P only. This is symbol, no? Be easy for belt or platform. Let's use the relative velocity formula. Velocity of belt with respect to platform. What is the velocity of the belt? VBP, I'll calculate. This will be zero. Velocity of the block. Velocity of block with respect to platform. Velocity of the block is 0. Velocity of platform is how much? Let it be V naught. So what direction velocity of block with respect to platform will be towards left. So VBP, in what direction it will be directed. Then now the friction on the block should act like this. Then velocity of the platform with respect to block, in what direction? It will be in this direction. Then now the friction on the belt, I should show here only, you'll get confused, I'm showing it here. In fact, I should show here only, below that one. This F is what? On the belt, that one. So look at this friction, due to friction, let this be mu. So what is this friction? Will be kinetic friction, or there's relative motion. So if you want, you write kinetic. Then what is Fk should be equal to? Fk should be equal to mu mg, mu k mg. Then what is the acceleration equal to Fk by m. mu kg. So what direction it will have acceleration? The block in this direction. So because of this friction, what happens? The block will accelerate after some time. After some time, what we see, the velocity of the platform is a constant, no? The velocity. So the belt what happen will be, it's a long belt. It's a long belt. One problem, if you can understand, you can manage anything asked on this. Okay, now the platform or the belt has come here. It will be constant. This will not change. Now tell me like where the block will be. At P1 only. The P1 point will be somewhere here, and the P2 point of the platform will be here. So this is the ground, no? So let me take a reference G. Look at the position of belt. Belt will move, no? So this will shift. So where the block what happen will undergo displacement. With respect to platform, it will move. Somewhere here the block, it will attain again the velocity of the platform. And now there is no relative motion and the friction will not act here. So call this is P3. So what is P1, P2? Distance moved by the block with respect to platform. And distance moved by the block with respect to ground means, so this will be the position A. How to calculate all these particular parameters? How to calculate all these parameters here? So time taken by the block to attain that velocity. So we know acceleration. So what is V naught equal to? How to calculate that particular V naught? V naught is given, no, finally. So what is the time taken? So it will acquire the velocity of the platform finally. So we know V naught should be equal to A into T. So V naught value is given. A is how much? Mu kg into T. So how much of time it will take so that the block will stop slipping with respect to platform? T, that one. This is what? T equal to 0. How much of distance it has moved with respect to ground? With respect to ground, how much of distance it has moved? Can we calculate this distance? GA is equal to can we calculate the distance GA is equal to, GA should be equal to A T square by 2. What is value of A? Mu kg by 2. What is T? V naught by mu kg whole square. So this should be V naught square by 2 mu kg. What is this GA? Distance moved by the block with respect to ground. Distance moved by block with respect to ground. Similarly, I want the distance moved by the block with respect to platform. P1, P2. Relative motion, you apply it and you calculate it. Or calculate the distance moved by the belt. Calculate, we know distance moved. So distance moved by the belt. So look at the position, how much the belt has moved in this particular time, the platform. This should be equal to how much? Its velocity is constant, no? It will not accelerate. V naught into T. V naught equal to, this will be V naught by mu kg. So what is the distance P1, P3? P1, P2 should be equal to, or P1, P3. This should be equal to GA minus displacement of platform. So what is this XP now? Displacement of platform. What is P1, P3? Distance moved by the block with respect to platform. Moved by block with respect to platform. So finally what happens? The block will come to rest with respect to platform. No relative motion. So therefore the friction will vanish here. So you can now, instead of leaving the block, shall I give some velocity? I think you can manage same thing, no? Then the velocity of block, if it is greater than that of platform, then that will determine friction. So the friction in what direction will act, the relative velocity, the relative motion will determine